We've talked about precipitation and we've talked about interception. It's now time to consider what happens to water once it enters the ground. We will begin our discussion with a series of definitions to describe physically how water occurs within the ground. And to start this off, I'm going to draw a cross section of some part of the subsurface. It can extend out here in 3 dimensions. And this subsurface will have some grains of minerals in it. And we will call this part here V sub solids. And this is the volume of solid material. So even though this is just a 2-dimensional slice, we can picture it extending back into 3 dimensions. Water may also be here, adhered on to these mineral grains. So V water will be the volume of water. And then finally, we have this empty space here, which is just air, V air. And we know that V water plus, oh, I've already made a mistake here in the colors. V solids plus V water plus V air is going to equal the total volume, V. Total volume. Now, I want to emphasize that the amount of water versus air versus solid that you measure actually depends on the size of the window that you're measuring. Imagine if you just considered a tiny little square here, you would get all air. If you considered a tiny little square here, you would get all solid. As you increase the size of the window over which you're measuring some physical property, you'll see that the proportion of these different things changes. But at a certain size, we hope that that variability decreases and that you kind of get a constant physical property. And this concept of the window size over which you're looking and the size at which you have a representative volume is known as the representative elementary volume. Or the REV. And it's the volume over which a measurement a representative measurement can be made. Representative. And we can illustrate this probably most clearly with a plot. So imagine that we're measuring some property. Maybe it's porosity or density. Doesn't really matter. And this is the volume or window size over which we're measuring. As we increase this volume, we might see a lot of variability. But at a certain point, the variability will diminish significantly because we're incorporating a big enough area that these variations cease to matter. This point is the REV, or the representative elementary volume. It's the size that's sufficiently big enough that we can get an adequate representation of the material.